Good morning, geometry. We are here today on this beautiful day. I think the sun might actually shine today, which is wonderful. And we're here today. We're going to do a review of Pythagorean theorem and special right triangles. We've done Pythagorean theorem since 6th grade, so hopefully everyone's familiar with that and can do that pretty quickly and easily. There are just a few problems where it's asking you to solve for a side of a Pythagorean theorem triangle, a right triangle. So we know that in every right triangle, the Pythagorean theorem tells us that a squared plus b squared equals c squared, where a is one of the legs, b is a second leg, and c is always the hypotenuse, right? So leg squared plus leg squared equals hypotenuse squared. Got to be careful with that hypotenuse thing. Okay, so we've got also this idea that we can use that Pythagorean theorem concept to determine if three sides of a triangle are either a right triangle or an acute or an obtuse triangle. So of course, if you're given three sides of a triangle, then if a squared plus b squared equals c squared, then of course it's a right triangle, right? If you're given, hold on, I'm going to go get my sheet. If you're given three sides of a triangle, like you will see on the sheet that I'm giving you today, all right? So they just give you these three sides. Then you set it up and throw it into a calculator, set it up like Pythagorean theorem, like I did in the examples. And if a squared plus b squared is greater than c squared, if the two shorter sides, their squares add up to more than the third side squared, then it's an acute triangle. And if a squared plus b squared, these are the two shorter sides, are less than c squared, the longer side squared, then it's an obtuse triangle. Okay? So this is if you think about that logically, it makes sense. If a squared plus b squared equals c squared, then something has to shift if what would be the hypotenuse is longer or shorter than an actual hypotenuse. Okay? So there's one quick side of the paper asking you to do some Pythagorean theorem, one asking you to understand this concept here, and then we've got our special right triangles. I'm almost certain we have talked about these in class. So if you look up special right triangles, you can find this on almost every single math website. So this is a quick review. In a 45-45-90 right triangle, or an isosceles right triangle, where the two legs are equal to each other, if we take that through the Pythagorean theorem and then simplify the radical, we find that the hypotenuse equals a times root 2. So if a is 3, then the hypotenuse is 3 root 2. If the hypotenuse is 3 root 2, then the sides are 3. Okay, so we can go backwards. We would multiply by root 2 to get the hypotenuse, or divide by root 2 to get the side. All right? In a 30-60-90 right triangle, which is half of an equilateral triangle, so it's drop down that altitude and cut it in half, and you get half of an equilateral right triangle. If we call the short leg A, then of course the hypotenuse is 2 times a, because an equilateral triangle has 3 equal sides. So the hypotenuse is 2a. So I always work from the short leg and I say 2a, or I divide by 2 and get the short leg. And then it's a short leg times root 3. If we took this through the Pythagorean theorem, if we took this longer side and the shorter side, and we use the 2a, then we would get root 3, a root 3. So if I know the short side, then I can multiply by root 3 to get the long leg. Not the short side, the short leg to get the longer leg, and then double that to get the hypotenuse. Does that make sense? Okay, if anyone wants to talk about this today, please let me know. If you're not feeling like this is a quick review, then contact me and we can go over it together. Again, there are lots of math sites that show you and explain all of this in the same way. So there are 4 sides of, front and back of the study guides. And I think that the whole, even listening to this long video, will take you less than half an hour. So if it's not, then reach out to me and I will help you. Okay? I hope that all is well and that you have a wonderful day and get outside this afternoon. Bye.